So let's prove those three positive negative argument rules in your trig proof toolbox. So before we go into that, let's just remember the difference between a positive angle and a negative angle. I didn't make the rules. I was not part of that committee that said this is a positive angle. I was not part of this committee that said this is a negative angle. So the idea is if you start at the x-axis on the right side in the xy, then if you go if you go counterclockwise, you're going in the positive direction. So if we start here, 90, 180, 270, and a full rotation is 360. Okay, whereas if we want to go the negative direction, it's clockwise. So we start out at 0, negative 90, negative 180, negative 270, and negative 360. So if you'll notice, if you compare and contrast, that positive a positive 90 degrees has the same terminal point as negative 270 degrees. Positive 180 degrees has the same terminal point as, well, negative 180 degrees. And 270 degrees in the positive direction has the same terminal point as negative 90 degrees. And finally, 0 degrees, 360 degrees, 0 degrees, negative 360 degrees, those are the same terminal points. So just to make it clear that the positive angle goes counterclockwise and a negative angle goes clockwise. Okay? Now, I reviewed that. So for example, let's say I take 30 degrees. 30 degrees is in quadrant 1, where the x value is the cosine and the y value is the sine. So according to our calculations, the 30-degree angle has a cosine of radical 3 over 2. And the sine of 30 degrees is 1/2. This should not be news to you based on the unit circle. However, what would be the negative equivalent? So, hint, 30 plus what is 360 degrees? If we wanted to go the negative direction to get the same cosine and sine, we would have to go past the negative 90 degree angle mark, past the negative 180 degree mark, past the negative 270 degree mark, not quite 360, so that 30 degree angle starts here to there at the same terminal point to go negative 330 degrees. So the positive angle went 30 degrees counterclockwise. However, the negative angle went 330 degrees clockwise, even though they ended up at the same terminal point. That's the flexibility that we show when we go clockwise versus counterclockwise. Okay, turn the page. Okay, so remember the unit circle, okay? If this is in your notes, awesome. You don't need to recopy this down. But if we start out over here, cosine comma sine is both positive in quadrant 1. X, y are positive. In quadrant 2, the cosine is negative, the sine is positive. In quadrant 3, the cosine is negative, the sine is also negative. And finally, in quadrant 4, the cosine is positive and the sine is negative. So why am I going over this yet again? So let's say I get my pencil, and let's say I want to go 30 degrees. So yet again, I go 30 degrees. Let's say I want to go 30 degrees positive. And let's say I want to go 30 degrees negative. Okay? So I'm not going to write down the specifics, but remember in quadrant 1, the cosine is positive and the sine is also positive. If I go to quadrant 4, right, if I go 30 degrees positive, 30 degrees negative, that means that the cosine is positive, but the sine is negative. Okay, so what can I conclude from this? Well, if I go a positive angle, right? If I go a positive angle, the cosine is exactly the same, and the cosine is exactly the same. If I go a positive angle, the sine is positive, but the sine is negative over here. Let me just confirm that with the calculator. Once again, mode, degrees. The cosine of 30 degrees, radical 3 over 2, 0.866. But if I go cosine of negative 30, it's also 0.866. Let's compare the sine of 30 degrees. 1/2. Let's compare the sine of negative 30 degrees. Negative 1/2. Let's say I go 120 degrees. Right? 120 degrees will have a negative cosine and a positive sine. Negative 120 degrees will have negative cosine, negative sine. So the cosines seem to match up no matter what angle I pick. Therefore, that's why the sine of a negative angle is the same thing as the sine of its positive angle, but with a negative in front. And the cosine of a negative angle is a mirror image. The cosine of a negative angle is the exact same as the cosine of its positive angle. So one proof for today. Well then, what does tangent of negative theta equal to? So what happens if I take the tangent of a negative angle? Okay, well, recall that the tangent of an angle is equal to the sine of that angle divided by its cosine. Well, if that's the case, then I can rewrite this as tangent of negative theta is equal to sine of negative theta over cosine of negative theta. And then let's see some magic. Let me get my multicolored pen. I know that the sine of negative theta can be rewritten as negative sine of theta. And I know that cosine of negative theta can be written as positive cosine of theta. All I did here was factor out the negative. So now I've got sine of theta over cosine of theta. And therefore, sine of theta over cosine of theta is tangent of theta. So therefore, that's why those three rules are tangent of negative theta is equal to negative tangent of theta. So that's what proves the third rule. It's kind of a light day today, but I just wanted to make sure.